Hello all. In continuation with the last video, we shall start solving some more problems on tape corrections. First I'll read out the second numerical for you people. A line was measured with a steel tape which was exactly 30 meter at 25 degrees Celsius at a pull of 10 kg. The measured length being 1700 meter, the temperature during measurement was 34 degrees Celsius and the pull applied was 18 kg. Compute the length of the line if cross-section area of the tape is 0.025 centimeter square. Take alpha is equal to 3.5 into 10 raised to the power of minus 6 per 1 degree Celsius and E as 2.1 into 10 raised to 6 kg per centimeter square for the material of the tape. Now we shall read out the problem once again slowly and we shall analyze it and write down all the given data. Now it is given in the question that a line was measured with a steel tape which was exactly 30 meter at 25 degrees Celsius and at a pull of 10 kg. The measured length was 1700 meter. And in the next line or in the next sentence they have given the temperature during measurement was 34 degrees Celsius during measurement. This means the details which is given in this sentence, it is with regard to the field or during the surveying. So the given data over here, it is the standard temperature. So we shall write it down first. First it is given the length of steel tape, it is 30 meter, that is small l, we shall write it down as 30 meter. Then temperature, that is the standard temperature, it is T0. T0 is equal to 25 degree Celsius and the pull, it is also the standard pull. So we have to write it as P0, it is equal to 10 kg. Then they have also mentioned that the measured length, it was 1700 meter. So the capital L is 1700 meter. Then again the temperature during measurement, it is Tm, it is given as 34 degrees Celsius, 34 degrees Celsius. Then the pull applied during the measurement was 18 kg. So P is equal to 18 kg. Till now it is clear. Now all the other data it is given directly here. The cross-sectional area of the tape, it is given as 0.025 centimeter square. So A is equal to 0.025 centimeter square and alpha is given. We have to write it write it as it is. Then E is also given directly, so we have to write it as it is. Now using this given data, it is very easy to solve the problems. The only thing we have to do is we just have to substitute the given data in the known formulas. So first, using this data, we shall see what are the corrections that we can find it out. So using temperature, we can find out the correction for temperature, isn't it? So Tm, T0 is given and alpha is given. So all the data are given to for the correction of or for the calculation of correction of temperature. Next correction is correction for pull. For correction for pull, we need area, then the pull, that is standard pull and pull during during the measurement, and even the measured length, that is capital L. So it is all the data are given. Two pulls is given, E is given, A is given, then L is also given. So we can calculate both the corrections, that is correction for temperature and correction for the pull. Now using the formula, we that is Ct is equal to alpha into Tm minus T0 into L. Alpha is given, that is 3.5 into 10 raised to the power of minus 6 into Tm, that is temperature in the field 34 degrees Celsius. Then T0, it is 25 degrees Celsius and L is measured length of line, that is capital L, 1700 meter. By substituting this and after solving this, we have Ct is equal to 0.0536 meter. So this is the resultant, it is in the form of positive, so we have to keep it as positive itself. Then coming to the next one, that is correction for pull. So for correction for pull, we have the formula, it is something like this: Cp, it is equal to P minus P0 divided by A into L. P, we know what is P. Here we have written P is 18 kg, then P naught is 10 kg, L is 1700 meter, A is given in the question, and E is also given in the question. So by substituting all these things in the formula and solving it, we will get the correction for pull as 0.2591 meter. After this, we have to calculate the total correction. So in the question what they have given is, compute the length of line. So what does it mean? We have to apply the correction. First, before applying the correction, we have found out two types of corrections. That is, one is correction for temperature and other is correction for pull, isn't it? So now we are doing the summation of these two. Both the correction is positive, so we are keeping it as positive itself. That is, CT it is 0.0536 and CP it is plus 0.2591. So by summing, after summation of this, we have the total correction, that is 0.3127 meter. This correction you have to apply it for the measured length of line, that is capital L. Capital L is 1700 meter. So for that, the total correction obtained is positive, so you will add it up, 1700 plus 0.3127. You will get the resultant as 1700.313. You will round it off to the nearest value. Hope this is clear to everyone. Now we shall solve one more problem. Let me read out this problem for you. The third numerical goes something like this. A steel tape of nominal length 30 meter was suspended between supports to measure the length of a line. The measured length of line on a slope of angle 3 degree 50 minutes is 29.859 meter. The mean temperature during the measurement was 12 degrees Celsius and the pull applied was 100 Newton. If standard length of tape is 30.005 meter at 20 degrees Celsius and the standard pull is 45 Newton, calculate the corrected total length. And some of the given data are like this. Take the weight of tape as 0.15 Newton per meter, then cross section area it is 2.5 mm square. Then they have given alpha and E as alpha as 1.1 into 10 raised to power minus 5 per degree Celsius and E as 2 into 10 raised to power 5 Newton per mm square. So this is the given numerical. So out of this given numerical, we have to take out the given data from that. The data which we want, we have to take it out from that. Here we shall slowly read the question once again and we shall start noting down the given data. A steel tape of nominal length 30 meter. So the length of steel tape is given, that is small l. We have to write it down. Small l is equal to 30 meter. And it is said that it was suspended between the supports to measure the length of a line. And the measured length of line, it was on a sloping ground and it was with the angle of 3 degree 50 minutes. See, in question they have given that it is suspended between two supports. It is suspended between two supports and they have mentioned that the measured length of line on a slope of angle. So that means these two lines, the ends of this line, it is not in the same level. So it has some difference in level, that is theta. So this theta it is given over here, that is 3 degree 50 minutes. So write it down in the given theta as 3 degree 50 minutes. And the measured length of line, that is capital L. This is the capital L, that is 29.859 meter. So capital L 29.859 meter. The mean temperature during the measurement. During the measurement in the sense in the ground. So it is Tm. Tm is 12 degree Celsius. You have to write it down. Then the pull exerted was, so it is also in the ground, so it is simply P. P is equal to 100 Newton. And in next sentence they have given all the standard data. If the standard length of tape is 30.005 meter, so you keep this aside. I'll explain this to you later. And continuing with the sentence, the standard length was so and so at a temperature. This is the standard temperature, that is T0. Write it down here as T0 is 20 degrees Celsius. Then the standard pull is 45 Newton, that is P0 45 Newton. Now they have said us to calculate the corrected total length. Now coming to this, that is 30.005 meter. Standard length of tape is 30.005 meter, and here also you can see it is given as nominal length as 30 meter. So with this two datas, they have given us indirectly the correction per tape length. Why does this correction per tape length is important? It is used in the correction of absolute length, isn't it? Small c. So using these two data, you have to calculate what is small c. You have to just subtract this standard length with the nominal length. That is 30.005 minus 30. You will get the small c, that is correction per tape length, as 0.005 meter. And coming to the next data is given. Here also the weight of the tape, it is not given directly. What is the unit for tape? It is Newton or kg, isn't it? So this is something new. What is given? The weight of the tape, it is given in the form of Newton per meter. So you have to convert it into Newton. What you will do? You have to multiply it with the length of the tape. What is the length of the tape? It is 30 here. Length of the tape, small l is 30. So you will multiply it with the length of the tape. What happens when you multiply it with the length of the tape? W, it is equal to 0.15 Newton per meter. It is given in the equation. So now what I said we will multiply it with the length of the tape, that is 30 meter. When you do this meter and meter gets cancelled, and you will get the value of weight of tape in the form of Newton. So the resultant obtained is 4.5 Newton. So this is how you have to calculate the weight when it is given indirectly. Then area, it is given directly, cross-sectional area, that is 2.5 mm square, and alpha is given, E is also given. So with all this given data, we have found out the weight, and we know all the given data, isn't it? Now using that, it is very easy and simple to calculate the correction of absolute length or correction for tape, isn't it? So now coming to the first correction, that is correction for absolute length. Using this given data, you can find out the correction for absolute length. Now the formula is CA is equal to L into C divided by small l. L is measured length of line. You have L as measured length of line, that is 29.859. You will write it down here. C is correction per tape length. You have find it out here. That is 0.005 meter. You will write it down. 30 L is length of tape, isn't it? So the length of tape is 30 meter. You will calculate you will solve this equation. You will solve this and you will get the resultant as 4.98 into 10 raised to the power of minus 3 meter, and it is in the form of positive. The resultant is positive. So you will keep it as positive. Then coming to the next type of correction, that is correction for temperature, CT. CT, you have the formula alpha into Tm minus T0 into L. Alpha is given. What is alpha? Given value is 1.15 into 10 raised to the power of minus 5. You have to write it down. Then Tm minus T0. Tm is given over here. That is 12, and minus T0, that is 20, and L, the length, measured length of line, that is 29.859. After solving this, you will get the resultant as minus 2.75 into 10 raised to the power of minus 3. As I said you earlier, if the correction for temperature, if you get it as positive, If the resultant, if you get it as positive, you have to keep it as positive. If the resultant, if you get it as negative, you have to keep it as negative. So you will keep the resultant or correction for temperature as negative itself. You can also write it in this form. Then the next correction, that is correction for pull, Cp. You have this formula for that. Cp is equal to P minus P naught into L divided by A into E. So you know what is P? It is 100. That is P is temperature at pull at the ground, and P naught is pull, that is the standard pull while manufacturing of the tape. Then L is the measured length of line, that is 29.859 divided by area, that is 2.5 mm square, and E is 2 into 10 raised to the power of 5. And here you have to see to that. What you have to see here, area it is given with the unit of mm square, and even in here Young's modulus of elasticity E, it is given as Newton per mm square. So you have to see to this units. It should also be the area and the unit for this E should be same. Here also it is mm square. Here also it should be mm square itself. If it is centimeter square, here also it should be centimeter square. You have to check for that before solving the problem. Then after substituting all the given datas, you will get after substituting all the given datas and solving for that, you will get the resultant as 3.28 into 10 raised to the power of minus 3 meter, and it is positive. Now we shall calculate other corrections also. So the next correction which we are going to calculate is the correction for sag. So this correction for sag, it is always negative. Now we shall see how to calculate it. And before getting into this, as we know that this is not like the ends of this line, it is not in the same level, it is in the different level. You have been given some value as theta. So you have some value theta given over here. First we have to calculate CS. You have formula, that is L W square divided by 24 into P square. Capital L is length of measured line. Then W is weight of the tape, W square divided by 24 into P, that is pull at ground or pull in the field of measurement, that is 100 square. And the resultant obtained, it is in the form of positive. The resultant obtained is positive. As I said you earlier, this correction for sag, it is always negative. So you have to write it down as negative, that is minus 2.52 into 10 raised to the power of minus 3 meter. And using for this, you have to apply once again the correction, as this is not in the same level as the theta is given, CS cos square theta. You will substitute in the place of CS, that is minus 2.52 into 10 raised to the power of minus 3, and cos square theta, here you have to substitute this, that is 3 degree 50 minutes. It is given here. Theta is equal to 3 degree 50 minutes. Then this, you will obtain this CS dash as minus 2.51 into 10 raised to the power of minus 3 meter. Then coming to the next type of correction to be calculated, that is correction for slope, that is CV. You have theta given over here, so you will calculate this. And this CV, it is also always negative. We shall see. We have the formula CV is equal to L into 1 minus cos theta. L is measured length of line into 1 minus cos theta. Theta is given slope angle 3 degree 50 minutes. Solving this, you will get the resultant as positive, that is plus 0.0668 meter. Then we know that correction for slope CV, it is always negative. You have to take it as minus, that is CV is equal to minus 0.0668 meter. Now it's time to calculate the total correction. So how to calculate the total correction? You just have to do the summation of all the types of corrections which you have calculated. So you have calculated the correction for absolute length. So this is positive, we will keep it as positive itself. Then correction for temperature, the resultant is negative, so you will keep it as negative. Then the correction for pull, it is positive, so you will keep it as positive. And here this correction for sag, you had obtained it as positive, but as it is always negative, you have to keep it as negative. So you have minus 2.51 into 10 raised to the power minus 3. Then CV also you got the resultant with the positive sign, but as it always has to be negative, you have converted it to the negative sign. So you have to write it down. This is correction for absolute length, which was positive. Then correction for this minus, it is minus because correction for temperature it was negative, plus correction for pull, it you got it as positive. Then after correction of pull, everything it is negative. So this is for correction for sag, and this is the value for correction of slope. After solving this, you will get the resultant as minus 0.0638 meter. So this is the total correction. You have to apply this correction to the total corrected to the length measured. So what is the measured length? That is capital L. It is 29.859. So as the total correction obtained is negative, you have to subtract it. So 29.859 minus this, that is 0.0638 meter. This is how you have to, and after solving this you will get this resultant. So this is the total corrected length, that is 29.795 meter. Hope this is clear to everyone. In upcoming videos we will be solving some more problems. Thank you.